So again, LEED for Homes is a comprehensive premier building program. You're going to start out by looking at energy, but you're going to also look at site development. You're going to look at, water efficiency. You're basically going to dissect the house and start from scratch. You sit down with the builder. If you're building your dream home and you want to live in that home for several decades, even if you were just going to flip it, which isn't, of course, what people are doing right now, given the economy. But even if it was a short-term investment, it's a wise investment to build a sound house that's certified, because you're actually going to have a higher return on investment and a higher resale value. But again, the overall breakout here that this diagram provides is sort of a breakout of the categories that you need to be considering when building a green home. Of course, we start with energy. We talk about water efficiency. We talk about maintaining the site. We don't want to cut down all the trees. We don't want to have a bunch of people drive their vehicles all over the site and compact the soil. We don't want to leave a bunch of trash on the site. We want to recycle the building materials. When the framers come in, the carpenters come in, we want them to use the building materials, the 2x6s, the 2x4s efficiently. We don't want them to be cutting and throwing, a third of them in a pile and burning them. So just basically stepping back and using materials efficiently. It's not that difficult. And then again, that all contributes to better air quality in the house and our health. So those types of things really touch upon particularly mothers when we talk about indoor air quality and the health of the home. And if they have kids, for example, that point really does hit home. So again, the consumer benefits are a healthier indoor air environment, more comfortable, more durable. We're working on houses that are 3 years old and they're already starting to have issues because the builders slapped them together, and now the consumers have to have us come back in and start fixing problems. And there is no reason for that. I mean, a house that's well built should last for decades and have very minimal problems. So again, there's huge energy savings associated with green homes. And then, of course, again, we're at a green expo. We need to be more environmentally conscious of what we're doing with our lives and how we're living. There's building benefits. The builder benefits from building a green home for the same reasons we just touched upon. They're going to be building a better quality house. They're going to be able to sell it for a premium. It's not going to sit on the market, and the consumer is ultimately going to be very happy and probably pass their word around, and they're not going to be calling them back to fix problems. So again, it's a smart decision for the builders as well. So again, this is the logo for the LEED for Homes program. And we're going to touch upon here a couple components of a high-performing home. This is spray foam insulation. We're going to have to breeze through these here. Windows, of course, when you harbor back to that picture of the house with all those leakage points, of course, windows are a break in the thermal envelope. Windows are a break in your shell. So you need to use good windows. So those basic components are insulation, windows. Then you talk about the heating and cooling equipment. Because remember that pie chart that we had, heating and cooling in the Mid-South. We live in a part of the country where we have equal load. We have about equal part of the year we have to heat and about equal part of the year that we have to cool. Other parts of the country just have to worry primarily about one or the other. We have to worry about both. So it's an extremely energy-intensive part of the country to live in because we all want to be comfortable. So again, that heating and cooling side of that pie chart was up to 50% of our energy usage. So using very energy-efficient heating and cooling equipment is also very important. But you need to start with your insulation. You need to start with good windows. Then you can worry about your heating and cooling system. This is actually a picture of a geothermal system, and that uses water. You're actually using the stable temperature of the ground. It's 58 degrees or so, and you're actually using a heat pump. It's just a glorified heat pump. I mean, it's a great heat pump, but it's a glorified heat pump, and you're using water instead of having to compete. And we don't need to get into complex engineering, but I mean, basically it's just using water instead of the air to be the resource in which to capture energy or to exhaust energy. And it's a very, very, very efficient system. This is a bar chart that indicates the efficiencies of a geothermal system on the left with a conventional system and two versions of a conventional system. So it's huge savings, and these systems last longer than conventional systems, so there's a durability factor as well. And these are 4 different models of a geothermal system. If you have a lot of land, you can go and put pipes about 6 feet down horizontally out in the field. If you don't have much land, you can, of course, drill wells, and it's just, again, not very difficult, and it's not a problem if there's rock. It actually is better if you have rock. So those are some of the layouts. This isn't difficult, and it's been done for decades. I also wanted to highlight upon this energy-water nexus, as they call it. Few of us recognize that, yes, a part of a green home is using energy more efficiently, using the building materials more efficiently, and using water more efficiently. But we don't recognize sometimes that there's a lot of energy encapsulated in that gallon of water that we use. The water has to be transported, it has to be purified, then it has to be distributed out to our homes. There's a lot of inherent energy that's inherent in that gallon of water that we use. So by using less, we're using also less energy. In our cities, I mean, the mayor was up here, and there's cities all around the country that are having to rework their stormwater systems, spending billions of dollars trying to rework our infrastructure. So using less then doesn't create quite a demand on our stormwater systems and our treatment systems and so forth, and we don't have to invest quite as much in all that infrastructure cost. So that's a detail that we need to keep in mind is that connection between energy and water. And then some of these things that, everyone's switching over to what they call front-end loaders now. We used to be using those old, huge, top-mounted washers and dryers, and extremely inefficient, using upwards of 50 gallons per load. These new units now, most of you have seen these. I mean, basically most of the appliance purveyors, they are all converting over to offering these units. And they use a fraction. They use around 15 gallons or so per load, 15 to 20. So that's less than half what the older units use in terms of water consumption. And then basic things that you can do in your own home, changing your shower head. I mean, we all talk about changing our light bulbs, converting to the complex fluorescent light bulbs, and we've probably all done that. But changing the shower head in our homes is also a simple, straightforward thing to do, and it saves a lot of money because you're saving water. And then, of course, as we just indicated in the previous slide, you're saving energy as well because you don't have to spend so much gas or electricity heating the water because you ultimately, of course, want to take a warm shower. And again, there's no sacrifice in comfort. Actually, some of the older, inefficient shower heads actually don't create as much pressure as the new shower heads that use a half as much water. So you're not sacrificing comfort. It's not as if you're going to have a little drip coming out and you're not going to be pleased with it. So basic things. The other picture here is a faucet we retrofitted down to a half a gallon per minute from, I think it was over a gallon and a half per minute. How much water do you need to brush your teeth? Unless you're going to be drinking out of your faucet, it's going to be a bit long. It's going to take a while to get enough water out of the faucet at a half gallon per minute. But as long as you're just adding some water to your toothbrush and brushing your teeth, which is normally what you do in a faucet sink in the bathroom, you don't need a gallon and a half per minute. So just basically rethinking some of our behavior patterns like we talked about. That definition for sustainability is just sustained behavioral change. Just doing some of these basic things makes a lot of sense. And then some outdoor solutions. You've probably heard of capturing rainwater. These are some systems here that are a little more professional, but again, it just can basically boil down to getting a clean 55-gallon drum, and there's a way to do it without oversimplifying it, but basically it's just capturing some of the water runoff from your house and using that to water your plants, and that can save a lot of water, especially in the summer when we have droughts. It decreases the load and the demand on our lakes and our streams and so forth to supply water. And it's actually better for our plants because it doesn't have the chlorine and some of the other chemicals that they have to use to treat. So again, lots of side benefits. And then again, from a municipality standpoint, from stormwater standpoint, building parking lots, like here in Chattanooga, building parking lots and driveways and so forth that use permeable surfaces. There's permeable concrete. I believe there's someone in the Expo here that has permeable concrete. There's permeable pavers. This is actually a German product, but sold in the U.S. And there's other U.S. Products that allow you to create, again, rethinking. Part of that name of my company, Innovate, is just to sort of rethink some of the things that we've been doing. Is it wise to create huge, expansive parking lots with asphalt that then, when you have a massive rainstorm, create a ton of runoff that the city then has to try to export through an infrastructure to the lakes and streams and dump it in there? It doesn't make much sense. So again, rethinking the way that we create some of our infrastructure is also a key to creating a more sustainable and a green city and also a green home.